Hello everyone. Chapter 9, Right Triangles and Trigonometry, Section 9.1, Pythagorean Theorem. Hopefully you are familiar with the Pythagorean Theorem. You want to become familiar with these Pythagorean triples, especially 3, 4, 5s and 5, 12, 13s. They're the most popular and common ones. They're used all the time on MCAS and the SATs. Example 1. Find the value of x. Tell whether the sides form Pythagorean triple. So, Pythagorean theorem, c squared equals a squared plus b squared. I know you're used to middle school telling you it's a squared plus b squared equals c squared. It's the same thing, but I want you to get used to writing c squared first. That's going to become important when we do the converse of the Pythagorean theorem and the converse of the Pythagorean theorem inequalities. So, for now, we're just going to put c squared equals a squared plus b squared. We'll find out why later. C is always the hypotenuse, which means it's always the longest side. So in this problem, it's x. X squared equals 4 squared plus 5 squared. X squared equals 16 plus 25. X squared equals 41. And at this point, we don't want the value of x squared, we want the value of x. Square root both sides, x equals square root of 41. Now, in algebra, that would be plus or minus the square root of 41, but since this problem relates to a geometric figure and x can't be negative because it represents the length of the side of a triangle, it's just the positive square root of 41. Example 2. Again, find the value of x and then tell whether or not it's Pythagorean triple. Oh, sorry. Back here. This is not a Pythagorean triple because the side lengths are 4, 5, and square root of 41. Pythagorean triples are always integers, whole numbers, positive integers. Square root of 41 is irrational. Okay, so find the value of x. Again, we start with c squared equals a squared plus b squared. C squared in this particular problem is 25, not x. 25 is the hypotenuse opposite the right angle. 25 squared equals x squared plus 15 squared. 625 equals x squared plus 225. X squared equals 400. Again, we square root both sides. X equals 20. And we find out we have 15, 20, 25. That is a Pythagorean triple. It breaks down, it comes from 3, 4, 5. So yes, this is a Pythagorean triple. Okay. Had you recognized 3 blank 5, because both of these reduce down by 5 to get a 3 and a 5 here, so 3 blank 5, then you could say 3, 4, 5. 4 times 5 is 20, and you can get your answer a little bit quicker if you know that it's Pythagorean triple from the beginning. And the more you do these problems, the more you start to recognize Pythagorean triples. Example 3. The flagpole shown is supported by 2 wires. Use the Pythagorean theorem to approximate the length of each wire. So, in this particular problem, x, again, is a hypotenuse. We have 8.5 feet here and 15.1 feet here. So again, we start with c squared equals a squared plus b squared. C squared in this problem is x squared. 8.5 squared plus 15.1 squared. X squared equals, let me pull out my calculator. Turn it, so I have the squared button. 8.5 squared, 72.25 plus 15.1 squared, 228.01. Add those together, plus 72.25 x squared equals 300.26. Square root both sides. Again, we'll let the calculator do that. And we get x as approximately equal to 17.3 feet. So each wire is approximately 17.3 feet. Okay, converse of the Pythagorean theorem tells us if the triangle is a right triangle or not. In the Pythagorean theorem, you know you have a right triangle when you're finding a missing side. Converse of the Pythagorean theorem, we have all three sides and we're trying to find out, is it a right triangle or not? So, and this is the reason this theorem and the Pythagorean inequalities theorem are the reason that we're going to have c squared come first. In fact, I'm going to use the Pythagorean inequalities theorem to do example 4a and b in addition to 5 and 6. So we're going to put c squared blank, accidentally hit the pause button. So add these two numbers together, we get 300.26. Take the square root of both of those and you're going to get 17.3 feet. So the length of each wire is approximately 17.3 feet. Converse of the Pythagorean theorem is used when we have three of the side lengths of a triangle known, but we don't know what type of a triangle it is. Is it a right triangle? We're using the converse of the Pythagorean theorem to find out. We use the Pythagorean inequalities theorem to find out if it's an acute triangle or an obtuse triangle. And these are the reasons that we're going to put c squared first, because for an obtuse triangle, the c squared is going to be bigger than the a squared plus b squared. And for an acute triangle, the c squared is going to be smaller than the a squared plus b squared. And if you put them in the other order, then your less than and greater than symbols can be a little bit confusing. So we're going to put c squared equals a squared plus b squared, for example, 4a. And how do I know which one to put into the c, the a, and the b? I don't have a right angle. I don't know if I have a hypotenuse or not. The c is always going to be the largest of the three sides. 12 is the largest of these three sides. So we're going to have 12 squared blank. Again, still blank because we don't know if it's equal, greater than, or less than yet. 8 squared plus 4 square root 5 squared. And that's the only one that can be a little bit tricky. We'll talk about that in a second. 144 blank 64 plus, all right, 4 square root 5 squared. 4 squared is 16. Square root 5 squared. Square rooting and squaring cancel each other. So the square root of 5 squared is just 5. 144 blank 64 plus 16 times 5 is 80. 144 equals 144. Since they are equal, then we know this is a right triangle. Part B, let's find out. C squared blank a squared plus b squared. Again, 9, 14, 2 squared, 30. 14 is the largest of these three sides, so 14 squared blank. 9 squared plus 2 square root 30 squared. 15 squared is 196 blank. 81 plus, and again we have to do this, I only wrote 3, it's 30. I have to square each part, so 2 squared is 4. Square root of 30 squared is just 30. They cancel. 196 blank. 81 plus 120. 196 does not equal 201. So what symbol do I put? So it's not a right triangle. We know that already. Converse of Pythagorean theorem. We know it's not a right triangle. What symbol am I putting in here? 201 is bigger than the 196, or the 196 is smaller than the 201. So I put a less than symbol in. When you see less than, you think, or the c squared is smaller than the a squared plus b squared, then it is an acute triangle. Not a right triangle, it is an acute triangle. Okay. Example 5. Verify that the segment lengths of 14, 15, and 11 form a triangle. First of all, we should make sure that they actually form a triangle. And 11 plus 14 is 25. That's bigger than 15. It does make a triangle. And then determine, is a triangle acute, right, or obtuse? So to save some space up here, I'm going to do the work up here. C squared blank a squared plus b squared. Keep it straight for you. Biggest number is 15, so that's got to be our C. 15 squared blank, 14 squared plus 11 squared, 225 blank, 196 plus 121. 225 is less than 317. Therefore, this is an acute triangle. Okay. Example 6. A right triangle has lengths of 16 and 30. Find the length of the hypotenuse to the lengths of the sides, form Pythagorean triple. So again, we know that this is a right triangle, so the Pythagorean theorem applies. We know 2 of the 3 sides. We're going to find the third side and see if it forms a Pythagorean triple. So c squared, and we're told that we're looking for the hypotenuse, so we're looking for the c value. C squared equals a squared plus b squared. C squared equals 16 squared plus 30 squared. C squared equals 256 plus 900. 256 plus 900. C squared equals 1156. Square root both of these. C is approximately equal to not approximately equal to anything. It is exactly equal to 34, which means we have 16, 30, 34, which is a Pythagorean triple. Yes, they do make a Pythagorean triple. Example 7, as a fan of baseball, is one of my favorite problems because it simply explains why base runners in baseball and in softball are more likely to steal second base as opposed to stealing third base, and you'll find out why in a second. So baseball diamond is really just a square with 90-foot sides. So each side length is 90 feet. So from home plate to first base is 90, first to second is 90, second to third is 90, third back to home is again 90. So home plate and second base are opposite vertices of the square. Here's home plate. Here's second base. Round to the nearest foot. How far does the catcher have to throw the ball from home plate to second base when the runner only has to run 90 feet? Again, that's a right angle. They're all right angles because it's a square. So this is 90. This is 90 feet each. This is the hypotenuse because it's opposite the right angle. So c squared equals a squared plus b squared yet again. C squared equals 90 squared plus 90 squared. C squared equals 8100 plus 8100 16,200. Square root both sides, and we want to round this to the nearest foot. So I hit my square root button. C is approximately equal to 127 feet. Okay, which means that the catcher has to throw the ball 127 feet to the second base to try and catch the runner stealing second. Now, if the runner's on second trying to steal third, the catcher only has to throw the ball 90 feet to try to catch that runner. The runner, in both cases, is traveling the same distance. The runner going from first to second goes 90 feet. The runner going from second to third goes only 90 feet. But the ball going from home plate to second base has to travel a little bit more than 37 feet further than it does when it travels from home plate to third base, making it much harder for the runner to get caught going to second, much easier for the runner to get caught going to third base. Okay. Question number 8. The hypotenuse of an isosceles right triangle has a length of 20 centimeters. Find its area. So we're told a couple things here. We're told that it's the hypotenuse, and we're told that the triangle is isosceles and a right triangle. So, quick sketch. This is A. This is also A because it's isosceles. And this is 20. So C squared equals A squared plus A squared. If you want to put A squared plus B squared, you can, but A and B are the same. 20 squared equals 2A squared. 2A squareds there. 400 equals 2A squared. Divide both sides by 2. Now I know some of you are going to make the mistake thinking that this is like this problem, or this problem, where we had to square the 2 and square the square root of 30. It is not. This 2 is not being affected by this squared. Divide both sides by 2. A squared equals 200. Both sides. Again, A equals, this time I'm going to do simplest radical form because it's actually easier for this problem. So in this problem we get 10 square root 2. It's the square root of 200. Why did I do simplest radical form? Because in reality we're finding the area of this triangle. And the area of this triangle is 1/2 base times the height. Area equals 1/2 base times height. 1/2 10 square root 2 times 10 square root 2. That's 10 square root 2 squared, which is 200. Since we just found the square root of 200 is 10 square root of 2, square this 10 square root of 2, you get 200. So the area equals 1/2 200. Area equals 100 centimeters squared, since we knew what the units were. Okay. Example 9. Is a triangle with side lengths 4, 6, and 7 a right triangle? First of all, is it a triangle? 4 plus 6 is 10. That's bigger than 7, so yes. Is it a right triangle? Let's take it a step further and find out what type of a triangle it is. C squared blank, A squared plus B squared. 7's the biggest number. 7 squared blank, 4 squared plus 6 squared. 49 blank, 16 plus 36. 16 plus 36, 52. 49 is smaller than 52. It's less than 52. Therefore, this is not a right triangle. It is an acute triangle. Okay, example 10. The numbers represent the lengths of the sides of a triangle. We can confirm that. 15 plus 20 is 35. That's bigger than 25. Makes a triangle. 10 plus 15 is 25. That's bigger than 20. Those also make triangle. Classify each triangle as acute, obtuse, or right. I'm going to do part A first. I'm going to do c squared blank a squared plus b squared. C is being replaced with the 25. 25 squared blank 15 squared plus 20 squared. 625 blank 225 plus 400. 625 equals 625. Therefore, part A is a right triangle. Part B, c squared blank a squared plus b squared. This time we're replacing the c with 20. 20 squared blank 10 squared plus 15 squared. I should pause and say on part A, if you recognize each of these reduced by 5, you get 3, 4, 5. That's Pythagorean triple. Then we knew it had to be a right triangle. These each reduced by 5. 2, 3, 4 is not a Pythagorean triple. 2, 3, 4 does not work in the Pythagorean theorem. So let's still figure out what type of a triangle it is. I can actually do it with 2, 3, and 4 using slightly smaller numbers here, make the arithmetic a little bit easier. But you're going to get the exact same answer because they're similar to each other. 400 blank 100 plus 225. 400 is greater than 325. And since we have greater than, we have obtuse triangle. All right, example 11 is a tricky problem. It is challenging. Find the integers j and k so that a, 4, 5, and j represent the lengths of the sides of an acute triangle, and 4, 5, and k represent the lengths of the sides of an obtuse triangle. So first thing we need to know is I don't even know if j and k are the longest, shortest, or in the middle lengths of these three sides of this of these two different triangles. So let's first find the range of what j and k can be. J has to be between 1 and 9. K also has to be between 1 and 9. Otherwise, we're not making a triangle. And again, I don't know if J is going to be the biggest of the sides or the smallest of the sides. We'll find out. If J is going to be the biggest of the sides and we want the triangle to be acute, then it's going to be J squared is less than 4 squared plus 5 squared. J squared less than 16 plus 25. J squared is less than 41. So J is going to be less than square root of 41. Square root of 41 is approximately 6.4, which puts it smaller than 9. Okay, so now I know J has to be smaller than square root of 41, which is about 6.4. But what if J is not the largest of the three sides? So we got to do this again. Now 5 is going to be the longest. 5 squared less than 4 squared plus J squared. 25 less than 16 plus J squared. Now I got to subtract the 16 from the 25. J squared greater than, I'm flipping things around, 9 J squared. J has to be greater than 3. So yes, J had to be between 1 and 9 to make the triangle. So doesn't K. But J, if we want that triangle to be acute, has to be between greater than 3, bigger than 41. So J's final answer J has to be between 3 and 41. Now we're going to do the exact same thing for K, only this time instead of greater thans or less thans, we're going to use greater thans. Now I'm not going to redo all of the arithmetic. It's going to be very, very similar, right? But the range of answers is not. So instead of redoing all the arithmetic, I'm going to put K is greater than square root of 41. Doing the same arithmetic, only it's greater than, and a K. This would be K greater than square root of 41. And over here, this would be K less than 3. And here's where these come into play. Yes, K has to be greater than 41, but it can't be greater than 9. So we've got K is between square root of 41 and 9. And K is between 1 and 3. It's going to be less than 3, greater than 1. So, or put a comma. 1 less than K less than 3. So our answer for J was right here. The answer for K, a little bit more complicated because we still have to make sure that it makes a triangle. Okay? Was example 11. That is a tricky, challenging problem. All right, 12. Also somewhat challenging and most definitely not drawn to scale. So here's a picture of the Hubble telescope. And astronomy, the Hubble telescope is orbiting the Earth 600 kilometers above the Earth. So this is 600 kilometers, and this is why I'm saying it's not drawn to scale, because the radius of the Earth is 6,370 kilometers, and that looks like it may even actually be smaller than the 600 kilometers. But that's irrelevant, because our goal is to find the value of x. Okay, so to do this, this is actually really a simple Pythagorean theorem problem, where our hypotenuse, this is another radius, so this is another 6,370 kilometers here. So our entire hypotenuse is 6,970 kilometers. So c squared equals a squared plus b squared. It's an equal sign here because we're going to learn when we cover our unit on circles that this line here is tangent to the Earth, and a radius to a tangent at the point of tangency forms a right angle. So that's something we're going to learn in chapter 10. So our c squared is 6,970 squared equals x squared plus 6,370 squared. So 6,970 squared, big number, that's okay. So x squared equals 48,580,900 minus 6,370 squared, and it's 6,370 squared, which is 40,576,900. X squared equals 8,004,000. And we're going to round this answer to the nearest 10 kilometers. So I'm going to square root this now. And we're going to get x is approximately. Now, you would think that the answer is 2,829 kilometers, but we're rounding to the nearest 10 kilometers. So the nearest 10 kilometers, not the nearest 10th, the nearest 10 kilometers is 30. 20 is too small, this is more than 25, so it rounds up to 30. So 2,830 kilometers. And there's the answer to example 12. 13. Geometry in 3Ds. The box on the right is a regular rectangular solid, so all of these angles that look like right angles are right angles. Use triangle ABC to find the length of D1. So D1 is a diagonal in this bottom rectangle, the bottom of this rectangular solid called a prism, which we'll learn about in chapter 11. So we're going to find the length of D1, 3 inches, 4 inches. I know my Pythagorean triples. D1 is 5 inches. Okay. Use triangle ABD to find the length of D2. So 2, 5, and D2. That's another right angle. So this one I'm going to have to do Pythagorean theorem because I don't have Pythagorean triple. D2 squared equals 2 squared plus 5 squared. D2 squared equals 4 plus 25. D2 squared equals 29. So D2 is the square root of 29. When we do the square root of both sides. Okay, can we generalize the steps in parts A and B? Use the fact that AC squared plus BC squared is equal to D1 squared. And then D1 squared plus BD squared is equal to D2 squared. Sure. D1 squared here can be replaced with this, which means that D2 squared is equal to AC squared plus BC squared plus BD squared. Okay. Now, use the formula you wrote to find the length of the longest fishing pole you can pack into a box with dimensions 18 inches, 24 inches, and 16 inches. So the longest line is going to be this D2, corner to opposite corner. Okay, D1 is pretty long, but D2 is going to be longer. It's the longest of all the sides. It's the same as if we went from C to this upper corner here, or B to this upper corner here. But D2 is the longest side length, and we're going to use this formula that we just discovered to find the length of the longest fishing pole if these are in inches. So I'm going to still call it D2 instead of fishing pole. D2 squared equals 18 squared plus 24 squared plus 16 squared. D2 squared equals 18 squared 324 plus 24 squared 576 plus 256 equals D2 squared equals 576 plus 256 plus 324. 11 56. Square root that number, and we've seen this number before. The fishing pole D2 is equal to 34 or a 34-inch fishing pole. Will fit. That's the largest we can get in there. Okay, example 14. Find the value of x. Again, how do we do this? Well, what type of a quadrilateral is this? All four sides are the same, making it a rhombus. Well, we just finished chapter 8 on quadrilaterals. I'm sorry, chapter 8 was similarity. Chapter 7 was quadrilaterals. And we know that a quadrilateral that has all four sides being the same is a rhombus. And what do we know about the properties of the diagonals of a rhombus? The diagonals of a rhombus are perpendicular to each other, just like they are for a kite. The diagonals for a rhombus are perpendicular, and that's how we're going to solve this problem, because now that we know that they're perpendicular, we have a right triangle. 3 is the hypotenuse. 3 squared equals x squared plus square root of 5 squared. 9 equals x squared plus 5. X squared equals 4. X equals 2. Find the value of x in problem number 15. So it's going to involve a little bit more algebra. 100 squared, I'm sorry, 10 squared, I jumped the gun. 10 squared equals x squared plus x plus 2 squared in parentheses. 100 equals x squared plus. Now, common mistake for students who took Algebra 1 last year and are forgetting what they need to remember is that this is not x squared plus 4. This is x plus 2 times x plus 2. Hopefully at this point in your mathematical careers you know your shortcuts, and you know that this is x squared plus 4x plus 4, making this 100 equals 2x squared plus 4x plus 4. We want to set this equal to 0, so we're going to subtract x squared from both sides. 2x squared plus 4x minus 96 equals 0. We're going to divide everything by 2. Make the math a little bit easier for us. X squared plus 2x minus 2.8 equals 0. And then we have to factor. Equals 0. So factors of 48 that can combine to give you a positive 2. X plus 8, x minus 6, x equals negative 8 or positive 6. But since x represents the length of the side of a triangle, negative 8 does not make sense. X equals 6 is the only correct answer for problem number 15. 16. Challenging problem. Find the value of H. PR is 21 units. So if PR is 21, QP, we're told is a hint, is X, and QR is going to be 21 minus X. Then we're going to have to find the value of H this way. Now, notice we're not told that this is a right angle up here. And in fact, it wouldn't be. 13, 20, 21 is not a Pythagorean triple. So this is not a right angle up here. So what we're going to learn later on, which is the geometric mean, does not apply to this particular problem. So instead, we're going to have to set up two Pythagorean theorems, and we're going to have to set them equal to each other to find the value of x and h. H is our final goal to find the value of. Let's start with the first one, which is pretty easy. 20 squared equals x squared plus h squared. Okay. The second one is 13 squared equals h squared plus 21 minus x squared. Okay. Solve this one for h squared, and we're going to solve this one for h squared. H squared equals 400 minus x squared. H 169 equals, I'm going to replace the h squared, the 400 minus x squared. 400 minus x squared plus, and we remember from a few minutes ago that this is not just 441 minus x squared. This is going to be 441 minus 42x plus x squared. Now, conveniently, the x squareds cancel. So we're not going to have to do any factoring. Thank goodness. We're going to be just solving for the x value here. Okay, so I'm going to 841 subtract them from both. So 841 169 equals 841 minus 42x. 42x equals 841 minus 169. 841 minus 169, 672. X equals 42x equals 672. X conveniently equals 16. Because this is a book problem. I got it from a book. X works out to be a nice number. H squared, which is our final goal, to find h, equals 400 minus 16 squared. H squared equals 400 minus 256. 400 minus 256. H squared equals 144. Again, convenient book problem. H equals 12.
Problem is usually defined as a state of difficulty that needs to be resolved.
Sorry about that. My computer must have thought I said that computer, which I didn't.
Here's something I found on
Computer,
the web.
stop.
Just
going to keep on going every time I say it. Okay, example 17. The sides of a triangle have the lengths x, x plus 4, and 20. Specify those values of x for which the triangle is acute, with the longest side being 20. So this actually is a little bit easier than the problem that we had earlier, because this time I am telling you that the 20 is going to be the longest side, and that's going to be an acute triangle. We're not going to be doing this for multiple types of triangles. So 20 squared has to be smaller than x squared plus x plus 4 squared. 400 has to be less than x squared plus 8x plus 16. 400 has to be less than x squared, 2x squared plus 8x plus 16. Subtract 400 from both sides, and I'm going to turn things around. 2x squared plus 8x minus 384 is greater than 0. Divide everything by 2 to make things a little bit easier. X squared plus 4x minus 384 divided by 2, 192, greater than 0. Let's factor. X plus 16, x minus 12, greater than 0. X is equal to negative 16 or positive 12. Since it's definitely not a negative value, it's got to be equal to the 12. But if x is 12, x plus 4 is going to be 16. Positive value of that. Coincidence? Probably not. So we've got 12, 16, and 20 are going to make an acute triangle. What else will make an acute triangle? Well, as long as the 12 stays smaller than the 16, as long as the 12 stays smaller than the 20, then x can be between 12 and 20. And we're going to get an acute triangle. All right. Problem number 18. Is triangle ABC acute, right, or obtuse? To answer that, we're going to have to find out what the length of AD is. To do that, we're going to have to find out the length of BD and AD, add them together. BD is easy. 3 blank 5. BD is a Pythagorean triple. It's 4. 3, 4, 5. DA, we're going to have to do a little bit of work, but not a ton. 4 squared equals 3 squared plus AD squared. 16 equals 9 plus AD squared. AD squared equals 7. So AD equals the square root of 7, which means that AB is 4 plus the square root of 7. And now we're going to use this in addition to the 4 and the 5 to find what type of a triangle this is. So let's do, start here. C squared blank A squared plus B squared. Now 4 square root 7. 4 plus 7 square rooted is 6.6. So the 4 square root 7 is big. 4 plus the square root of 7 is bigger than the 5. Okay, so 4 plus square root of 7 squared blank 5 squared plus 4 squared. 4 plus the square root of 7 is about 6.6. If we square that, we get about 44.1 blank 25 plus 16. 44.1 is bigger than 41. Therefore, this is an obtuse triangle. Okay. And the last thing I want to show you is my favorite proof of the Pythagorean theorem. There are literally hundreds, if not thousands, of proofs, different unique proofs of the Pythagorean theorem. This one's my favorite because it is pretty simple and straightforward. It was done by one of our presidents of the United States. Presidents are not usually known for their ability to do math problems. This president clearly was and did a very nice proof. But the addition to that is this is something that any middle school student could figure out and understand after they've been shown it. So we have 3 right triangles here. We also have a trapezoid. MNPQ is a trapezoid. And we know it's a trapezoid because this is a right angle, this is a right angle, makes MN parallel to PQ, converse of the consecutive interior angles theorem. So NM and PQ are parallel. That makes this a trapezoid. So the area of trapezoid MNPQ, area MNPQ is equal to the area of this triangle plus the area of this triangle plus the area of this triangle. Area of MNR plus the area of NRP plus the area of RPQ. Okay. Area of a trapezoid, 1/2 base 1 plus base 2 times the height of the trapezoid, which in this case is MQ. So base 1 is MN, base 2 is QP, and the height of this trapezoid is MQ. Okay? So the area of MNPQ is 1/2 of MN plus PQ, base 1 plus base 2, times MR plus RQ. And I'm going to simplify things in a minute here to make things a lot easier for us. I'm going to simplify things right now to make things a lot easier for us. Make it easier to see instead of using M's and N's and R's and Q's. Okay. All of this triangle here is congruent to this triangle here. This is A, this is B, and this is C. This is A, this is B, this is C again. Okay, so area of the trapezoid, base 1 plus base 2, A plus B, times the height, A plus B. So squared. Triangle MNR, area of triangle MNR, 1/2 base times height, 1/2 AB. Area of triangle NRP, 1/2 base times height, plus 1/2 C times C is C squared, plus area of triangle RPQ, again, area of 1/2 base times height, 1/2 AB. All of these 1/2s can be canceled. Just get rid of all of them by multiplying everything by 2. A plus B squared. We've done that a few times today. This becomes a squared plus 2ab plus b squared equals ab plus ab is 2ab plus c squared. Subtract 2ab from both sides. A squared plus b squared equals c squared. The Pythagorean theorem. Done very simply using the area of the trapezoid is equal to the area of these three triangles, knowing that all three of these triangles are right triangles and that these two are congruent to each other, proves the Pythagorean theorem. Thank you very much.